Driving on Mars is nothing like driving on Earth. Mars is about 140 million miles away, which means commands from Earth can take many minutes to arrive. Real-time control is impossible. Because of this, rover routes have traditionally been planned by teams of experts who carefully study images and terrain maps, looking for hazards like rocks, slopes, and sand. These routes are broken into short segments called waypoints to reduce risk. Until now, humans have handled this complex planning task. In this new research, scientists tested a vision-enabled generative AI system. The AI examined the same data that human planners normally use, including high-resolution images of the Martian surface and terrain slope and elevation data. Using this information, the AI identified bedrock and outcrops, boulder fields, sand ripples, and uneven ground. From there, it automatically selected safe waypoints and created a continuous driving route across difficult terrain. In other words, the AI learned to see the landscape, understand risks, and plan a safe path just like a human expert. Before sending any commands to Mars, engineers tested the AI's plan using a virtual replica of the rover, often called a digital twin. This simulation checked more than 500,000 system variables, ensuring the route would work safely with the rover's onboard software. Only after passing these extensive safety checks was the plan approved for real-world execution. The results were impressive. On the first test day, the rover traveled nearly 700 feet, using an AI-generated route. 2 days later, it completed another drive of over 800 feet again, following paths planned entirely by artificial intelligence. Both drives were completed successfully, marking the first AI-planned drives on another planet. This breakthrough could change how we explore space. In the future, AI could enable longer, faster rover journeys, reduce the workload on human teams, help robots react more intelligently to unexpected terrain, and automatically highlight scientifically valuable locations. This kind of autonomy is especially important as missions travel farther from Earth, where communication delays grow even longer. This moment isn't just about a rover driving on Mars. It's about a future where intelligent machines explore distant worlds with greater independence, paving the way for deeper discovery, smarter robots, and eventually, human exploration beyond Earth.